Okay guys, today we're doing 4.11. That is the mean value theorem, and a easier way to say this is MVT. We will just be calling it MVT from now on instead of a mean value theorem, or whenever you write it. You can just write MVT. And that's on the test as well. They'll accept the letters MVT. Okay, let's talk about what MVT is. Okay, first thing, let's just reach back into our repertoire of things that we have and find the average rate of change of the function below. Okay, so given this interval. So let's find the average rate of change here. And I put a little note to myself to do this on the side, but obviously I cannot do it on the side here considering I have to go to the next slide. So you might want to just write it on the side, and we're going to be using it again in the next slide. Find the average rate of change of the function below. Okay, so when you see those words, that should be the key to going f of b minus f of a all over b minus a. Yeah, that's what we studied a lot previously. So we're going to be doing f of, and what is b? B is this. This is your A and your B. So f of 1 minus f of negative 1 all over 1 minus negative 1. Okay, so we're going to plug 1 into the function here. 1 cubed is 1 minus 1 squared is 1 minus 2 times 1 is 2. So we got 1 minus 1 is 0 minus 2 is negative 2. Okay, that's what f of 1 is. Minus, let's plug in negative 1. If you plug negative 1 cubed, will be negative 1. Minus negative 1 squared, minus 1. Negative 2 times negative 1 would make it plus 2. So we got negative 1 minus 1 is negative 2 plus 2 is 0. All over. 1 plus 1, 2. So we got an average rate of change of 1. Okay. Let's go to the next slide here. I'm going to teach you guys what the mean value theorem is. What I would do is write down what the average rate of change was for this. It was negative 1 because we're going to need that in the future instead of having to redo it again, okay? Let's go forward. Okay, mean value theorem. If the function is continuous on the interval a to b and differentiable on the interval a to b, there is some number c in that interval, and I have it in 3 different ways here for you. Okay, the first one, where the instantaneous rate of change is equal to the average rate of change. Okay, this is the mean value theorem, where the instantaneous rate of change is equal to the average rate of change. Now, let's think of that in a more mathematical sense. Instantaneous rate of change means derivative. An average rate of change means f of b minus f of a all over b minus a. So we're saying the mean value theorem is where the derivative is equal to the average rate of change. Yeah? The derivative is equal to the average rate of change. Now, this is it verbally. Instantaneous rate of change equals average rate of change. This is it mathematically, or algebraically, as you might say. And then graphically, that would mean average rate of change, remember, is a secant line where you have 2 points and you draw a line between those 2 points. So that's my average rate of change. The slope of this is the average rate of change. And you're going to find a place where the instantaneous rate of change is the same. And remember, instantaneous rate of change means the slope at one exact point, or at a tangent line. Yeah? And this is your instantaneous rate of change. Okay, let's try a couple problems. Okay, find a value c such that the instantaneous rate of change is the same as the average rate of change. Now, on the test, they're going to give it to you like this, with algebra and an interval, okay? I want to show you how to do it on a graph here, and we can use that to check our answer as well. So we want to find where the average rate of change is equal to the instantaneous. The average rate of change is going to be the slope from negative 1 to 2. So let's put a dot at where it is at negative 1. That's the y value at negative 1, right? And the y value at 2. Okay, we want to connect these things. Now, I've never drawn a straight line on here with this thing, so let's see if I do it good. Oh man, that's beautiful. Okay, this is the average rate of change. The slope of it is, yeah? And remember, to find that slope, it's f of 2 minus f of -1 all over 2 minus 1. That's minus -1. And that's what we did earlier. That's average rate of change, right? Okay, average rate of change. Now, I'm going to take a little guesstimate. It looks like the place where the instantaneous rate of change would be equal might be like somewhere right around here. Where if you draw a slope that touches that line right there, the slope at that point is very similar or equal to the slope at this point. And this is the instantaneous rate of change, okay? That's where the tangent line is. That's a derivative. This is an average rate of change. It's what you learned in algebra. This is how you calculate average rate of change. Now remember, we are finding the C value such that the instantaneous rate of change is the same as the average rate of change. But we have the average rate of change now. I haven't calculated what the number is, but this is how you figure it out. I want to set it equal to the instantaneous rate of change. That's what the question's asking me to do. Find the C value such that the instantaneous rate of change is the same as the average rate of change. And they're saying C value. That just means find the X, yeah? I mean, it doesn't. You don't necessarily have to say a C, okay? So let's take the derivative, because that's what instantaneous rate of change is. 8x minus 5. That's the derivative. Now we're going to try to find this x value where the average rate of change is equal to instantaneous. That's what we're going to be calling the C value, okay? So let's figure out what this is. F of 2, we're going to plug in 2. That's going to give us 4 times 4 is 16 minus 10 plus 2, so it's going to be 6 plus 2 is 8. So it's going to be 8 minus, I'm going to plug in -1. Ignore those now. -1 will give me 4 for this whole term, if that's confusing you. I'll do it on the side. 4. If I plug in -1 here, that's going to give me plus 5. Plus 2 at the end. So we got 9, 10, 11. All over. 2 plus 1 is going to be 3 equals 8x minus 5. Okay, 8 minus 11 is going to be -3 over 3 equals 8x minus 5. It's going to be -1 is equal to 8x minus 5. And add the 5 over, so it's going to be 4 equals 8x. And divide by 8, so x is equal to 4 over 8, or the same as 1/2. And look, that's exactly where we said there would be a point at which the slope might be similar to this average rate of change here. So that's the C value guaranteed by the mean value theorem. Yeah? Now, let's just check all our work here. We said f of 2 is 8. 2 is 8. Yep. F of -1 is 11. F of -1 is 11. Yep. We divided. We got everything, right? Okay, this is how you do it graphically. This is how you do it algebraically. Yeah? And that's verbally. Okay, and this is the mean value theorem. And it is only true if differentiable. Look at this function. This function is totally differentiable on the interval we were looking at. It is smooth everywhere from -1 to 2. Okay, so this one's good. Let's go forward. Find the value of C such that the function below satisfies the mean value theorem of this from 4 to 8. Okay. Well, first thing you might want to ask yourself is look at the graph. You could say this is not differentiable everywhere. But all we care about is it differentiable on the interval we're looking at, 4 to 8. And from 4 to 8, right there to right here, that graph is smooth. It is differentiable. So let's do this graphically real quick again. Let's see what we get. Okay, if I draw this line here, That's my average rate of change because I drew the line based off of 2 points. That's what we call a secant line, right? That's an average rate of change line. Now, I'm just going to take a guess here. I mean, I'm just kind of... The slope looks very big right there. It's not similar to the slope of the average rate of change. It looks like it might be somewhere around here that the tangent line or the slope of the graph is the same as this average rate of change. And that's going to be my instantaneous rate of change line, right? So I'm thinking the answer is going to be somewhere around 5. So let's do it algebraically and see what the actual answer is, okay? So it says find the value of x equals c such that the mean value below is satisfied by the mean value theorem. When they write mean value theorem, that's telling me the derivative equals the average rate of change, and we just solve for the x value. So let's do that. Let's do the derivative of this. First thing, let's rewrite it. X minus 4 raised to the half. Oh, that does not look like a half, but that's what it is. Okay, so the derivative of this is going to be chain rule. A half x minus 4 raised to the negative half times the derivative of the inside, which is just 1. Okay, you can rewrite this whole thing, move this to the bottom, keep the ones on top. So it's going to be 1 over 2 square root x minus 4. There we go. There's my derivative. Okay, I'm going to set my derivative equal to my average rate of change. So f of 8, because that's my b value, minus f of 4, because that's my a value, all over 8 minus 4. Okay, let's figure out what this whole thing is. If you plug in 8 minus 4 is 4. The square root of 4 is 2. 2 minus, and let's just check that. 8, yeah, the y value is 2. Okay, at 4, plug in 4. 4 minus 4 is 0. Square root of 0 is 0. Okay, at 4, yeah, the y value is 0. We're doing good. Divided by 4 equals our average rate of change. Okay, let's take this over here. Looks like this will be easy to simplify. It's just a half, right? So we got 1 over 2 square root x minus 4 equals 1/2. Okay, 1 times 2 is 2. I'm doing cross multiplication. I mean, there's multiple methods to doing this one. This times 1 is going to be this. Okay, we're solving for x. So first thing I would do is divide by 2, which would cancel them out. So we're left with 1 equals square root of x minus 4. Okay, I need a square to get rid of that square root. Okay, so 1 squared is 1 equals, we're just left with x minus 4. Add the 4 over, so x is equal to 5. There we go. And that's about where I said it was going to be. I said it was going to be somewhere around 5. Now notice on my graph, I can't be exact. I'm guesstimating. The algebra is what tells me the exact answer. Okay, I think I got one more for y'all. Find the value x equals c such that the function below satisfies the mean value theorem. Okay, now you guys should know an absolute value does a weird sharp turn, which you can see here. And it occurs wherever it's equal to 0. So here you can see that the inside of here would be equal to 0 at 2. So you know it's going to do a sharp turn at 2. Now look at the interval we're focusing on. -2 to 5. In between there is 2, because we're looking from -2 to 5. Okay. There's a sharp turn in there. It is not differentiable on our interval, right? If it's not differentiable, mean value theorem, not guaranteed. Now it might still be possible, but it's not guaranteed, okay? So find the x value such that the function below satisfies the mean value theorem. Well, look, let's do it graphically. I'm going to draw a line here, the average rate of change line. Oh, that was absolutely horrible. But you can kind of get an idea of what the slope is here, right? The average rate of change is going to be like that. If you notice, there are only two slopes on this entire graph, and neither one of those slopes are the same as this slope. Therefore, there is no place where the average rate of change is going to be equal to the instantaneous. Okay? And if you want to know what that slope is, I mean, you can easily figure it out. It's just the f of 5 minus f of negative 2 all over 5 minus negative 2. If you plug in 5, you get 3, becomes 3 minus 5 is negative 2. Minus, if you plug in negative 2, you get 4 minus 1, negative 1, all over 7. This gives us negative 2 plus 1 is 1 over 7. That does, yeah, that looks about right. 1 over 7. That means that somewhere the derivative needs to have a slope of 1 over 7. If you notice here, the slope of this is either negative 1 or positive 1. There is never any other slope besides negative 1 or positive 1. So you would say there is no C value guaranteed by MVT from, let's say, negative 2 to 5 because y is not differentiable. There you go. There's our answer. It's not differentiable, so there is no place. Okay, guys, just to give you an idea when you might use this in real life, okay, I have a real quick story for you. I've traveled before to Dallas, and in Dallas they got a bunch of these things called toll roads. That means that you drive through this little doorway, and they clock your time, and they charge you some cash. So let's say I walked through or drove my car through this doorway at 10 a.m. Okay, and let's say the next doorway is 100 miles away. Okay, and let's say I go through this doorway. I went into this one at 10 a.m. Let's say I go out this one at 11 a.m. They're 100 miles apart. Well, I think you can safely say that I was speeding. Yeah, because my average rate of change, which is the distance divided by the time, yeah, 100 miles divided by the 1 hour means I traveled 100 miles per hour on average. Okay, since I have to change my velocities gradually, meaning my velocity is differentiable, that means that my average rate of change had to equal my instantaneous rate of change somewhere. So what they can do when they have these toll roads is if you did this, I'm not saying I ever did, but if I were to do this, travel 100 miles in 1 hour, they can say at some point in there, I was traveling at 100 miles per hour. Yeah? Doesn't mean I was always traveling at 100 miles per hour, but somewhere in between here, I was. Therefore, they can send me a ticket and tell me I was speeding. They don't know when I was speeding, but they know I was speeding somewhere in between these toll roads. So that's when the average rate of change is equal to the instantaneous. Okay, that's it.